So we ended yesterday with talking about the electron cloud and how if the electron cloud is dense, there is a high probability of finding an electron in that area, whereas if the electron cloud is not dense, then there's a less likelihood of finding an electron there. Today we're going to talk about quantum numbers, and quantum numbers are, in the most basic sense, a way to find and organize electrons. So to review a little bit first, Schrodinger's equation places limits on energies an electron can have. Basically, that these energies are quantized. The mathematical representation of those energies are called orbitals, which we got from Bohr. And spoiler alert, orbitals can have different sizes and shapes, which we'll talk about here in a couple slides. So in order to distinguish between orbitals, we have these quantum numbers. And there are 4 quantum numbers. Quantum numbers specify the properties of an atomic orbital and the electrons in those orbitals. It is insanely important that you remember that no 2 electrons can have the exact same 4 quantum numbers ever. And so that's a way to kind of check if you have the correct answers going into these problems. If your electrons have the same 4 quantum numbers, something has gone awry. So the first quantum number is the principal quantum number. And this is symbolized by the letter N, and it designates the principal or the main energy level. So possible values will be whole numbers, 1, 2, 3, 4, 5, 6, 7, with N equaling 1 being closest to the nucleus. As N increases, so does the distance from the nucleus. These are basically the same as Bohr's energy levels. More than one electron can occupy a given energy level. So a way to think about it is this principal quantum number is the most broad classification. The second quantum number is the angular momentum quantum number, and this is symbolized by the lowercase l, and it will indicate the shape of the orbital. So not every orbital would look like a sphere, as what comes to mind for me. So there are different shapes that these orbitals can have. An orbital shape split principal energy levels into one or more energy sublevels. So where the principal energy level or quantum number n is broad, this angular momentum number is slightly more specific. So when n equals 1, or that principal quantum number is 1, then there is one sublevel. And we call that sublevel 0. When n equals 2, there are 2 sublevels, and these sublevels can have a value of 0 or 1. So to figure out your possible values for your angular momentum quantum number, or L, you simply take n minus 1. So in this table, we're just going to look at these first 2 columns right now. If the principal energy level is 1, so n would be 1, minus 1, and we get 0, like we set up here. And so that would be the value for L. It is not indicating the number of possible sublevels. The number of possible sublevels is same with the quantum or principal quantum number. So if principal quantum number is 2, there's going to be 2 possible sublevels, and to figure out the values, you use this formula. The magnetic quantum number is symbolized by the letter M with a subscript L, and it will indicate the orientation of the orbital around the nucleus. And so these orbitals, remember yesterday we talked about them being three-dimensional. So this magnetic quantum number will help us indicate if it's along the x-axis, the y-axis, or the z-axis. Your orbital shapes and names, you can have a p orbital, and if the p orbital is present, you should imagine a sphere. When you hear about the s orbitals, these are going to be dumbbell shapes like the weights. And then the d and f orbitals, their shapes are very complex, and so I'm not too worried if you have those shapes memorized or not. So the larger the value of n, the larger the corresponding s orbital will be. So remember, s is the sphere orbital, or sorry, the dumbbell orbital, so it just increases their size. So here are images to show you what the p, s, d, and f orbitals look like. So the p orbital, like I said, is a sphere. Your p orbitals are your dumbbell shapes. Notice how their orientation changes. Your d orbitals, notice that they get more complex. And then the f orbitals are much more complex. It's also important to notice that their shapes are not the same. Their shapes also increase in complexity, as do the quantities. So notice how the d orbital has 5 possibilities and the f orbital has 7. So the possible magnetic quantum numbers in its entirety would be -3, -2, -1, 0, 1, +1, +2, and +3. So your f orbitals, they would include all 7 of these numbers because there are 1, 2, 3, 4, 5, 6, 7 possibilities. Your d quantum numbers here would be the -2 to the 2 to the +2 because there's 1, 2, 3, 4, 5 possibilities. So then your possibilities for your m sub l numbers for the p sublevel would be -1 to +1 because there are 1, 2, 3 orientations. And then lastly, this 0 right here is the only representation for this diagram right here because there's only one shape. The only thing that changes with the S sublevel is the size, and the size is indicated by n, your principal quantum number. So this right here would be an example of n equals 1. Notice how as we go this way, this orbital gets a little bit bigger, so we have n equals 2, and from here we increase in size yet again, so here our principal quantum number would be n equals 3. The last quantum number is quite possibly my favorite because I'm a nerd like that and have a favorite quantum number. And this is called the spin quantum number, and it's symbolized by the letter m sub s, and it indicates the direction of the electron's spin within each orbital. So regardless of the orbital, any of the other preceding quantum numbers for an electron, the only possible values of the spin number are +2 or +1/2 or -1/2. And each orbital, regardless of shape or orientation, can have those numbers, and it can hold a maximum of 2 electrons. So a way to think about an orbital is just to represent it with a circle or a square. And each orbital can hold up to 2 electrons, like I said here, and they have to have opposite spins. The spin number is the number that allows electrons to have a whole different set of quantum numbers. So we represent in a single orbital, here would be your first electron, indicating the positive spin, and then the second electron has the down arrow representing the negative spin. And so your spins have to have an opposite direction within an orbital. So this is a simple orbital representation. So here is a chart that shows you that how this is all kind of organized. So if we have our principal quantum number as 1, that tells us we can have 1 sublevel, and the first sublevel is always S. It is the simplest, it's always the first. The number of orbitals per sublevel is, so if we only have 1 sublevel, there can only be 1 orbital. And then the number of orbitals per energy level would be 1. And then the number of electrons per sublevel, each sublevel can have a maximum of 2. And since we only have 1 sublevel, we can only have 2 electrons as the maximum. You could have 1, but the maximum you can have is 2. And then the number of electrons per principal energy level would also be 1. You will eventually, we will do so much work with these quantum numbers that this table will pretty much become a non-factor because you will just have this memorized. And if you don't have it memorized, I will teach you how to use the periodic table to help you figure these bits of information out. So in summary, the total number of allowable orbitals in each principal energy level is equal to n squared. And then the number of electrons that can exist in a given principal energy level is 2 times n squared. And we get this 2 because there's 2 electrons per orbital. So for your assignment tonight, and I would like this due tomorrow, you need to complete, I don't think there's any practice problems. Let's just look at lesson review questions 5, 7, 9, 10, 11, let's see, 12, 13, and 14. So as a little bonus here, because I'm guessing your heads are about to spin right off your necks because you're so confused, let's look at number 9 from the lesson review questions. Okay, so number 9 says, what are the possible values of L in the third principal energy level, and then which sublevel does each of those L values represent? So if we go back to one of the very first tables here, we see that when n equals 3, the number of possible sublevels is also 3. So we need to have 3 possible sublevels here. So there are 3 possibilities, and then we need to name them. So if we go back here, we see, oops, I lied, we need to go back here again. And their possible values of L are going to be 0, 1, and 2. So if you wanted the formula to figure out values, you could use this, or you can just look at the chart. So to answer the first part of number 9, the possible values of L are going to be 0, 1, and 2. And then which sublevel of each of those L values represent. So what sublevels? So when we see a 0, we know that that represents the S sublevel. 1 represents the P sublevel, and when L equals 2, it will be the D sublevel. So here is the answer that I am looking for. And these patterns, anytime you see a 0, it will correspond to the S. 1 always corresponds to P, and 2 will always correspond to D. So to practice this again, if N equals 4, how many possible L values can we have? So notice up here that when N equals 3, the number of possible values for L was the same. So down here it will follow suit that we will need 4 L values. And so here we would have 0, 1, 2, and now we need our 4th one, which would follow and be a 3. So then we match these up. 0 matches to the S, 1 matches to P, 2 matches to the D sublevel. So then the last sublevel to fill will be the F sublevel. So this was just an example problem. This is not on the homework. So if we look at your lesson review question, let's look at number 10, lesson review question 10. It wants to know what the possible values of M sub L are if the electron is in the P sublevel. So we look back to this little chart that I showed you, and we're in the P sublevel. So the possible values of your M sub L would be the -1, 0, and +1. So -1, 0, and +1. That would be your answer. So hopefully that gives you a little bit of a head start. Shoot me text through that Remind app or emails. I won't check my email at home, so that app is going to be your best bet if you have questions tonight. I am expecting these problems first thing when class starts tomorrow. If you have questions, please make sure you're asking them prior to class as much as possible. And also, please read your 5.3.